Hi, I am Federica Ricci, and in this presentation I will talk to you about a project aimed at understanding the effects of obscuration on the characterization of the BLR in a sample of local hard X-ray selected AGN inside the BUS collaboration, in particular by focusing on the complementarity of the optical and near-infrared views. The near-infrared can probe deeper into the physical condition of the BLR, being about 10 times less affected by extinction than the rest frame optical, and sometimes can allow to detect broad components also in objects lacking broad Balmer lines in the rest frame optical. For this reason, we use the near-infrared the hard X-ray selection for a total sample of more of 300 unique near-infrared spectra to understand the systematics and uncertainties in the determination of three BLR properties, namely the full width of maximum, which is a proxy for the BLR clouds velocities, the broad line luminosity, which is often used as a proxy for the distance at which the element is photoionized inside the BLR, and the virial factor that encodes all the unknowns about the geometry and dynamics of the BLR. In our analysis, the virial factor is computed as the ratio of two independent black hole mass estimates, one based on the stellar velocity dispersion and the other called M-line, that is based on the full width of maximum of infrared lines like the helium-1, the Paschen beta and the Paschen alpha, and on the hard X-ray luminosity. We first show that the ratio of the full width of maximum of the broad infrared lines, either the helium-1, the Paschen beta, the Paschen alpha, or the average near infrared, the ratio to the broad H-alpha full width of maximum does not depend neither on the level of extinction experienced towards the BLR, as you can see in the top panels, nor on the X-ray column density, as you can see in the bottom panels. And for this reason, the full width of maximum measured from the H-alpha or from the near-infrared lines is unbiased with extinction and obscuration, at least until NH levels of 10 to the 23rd per centimeter squared. The quantity that instead is getting suppressed is the line intensity, as you can see in the bottom left panel, where the ratio of the H-alpha to hard X-ray luminosity is plotted as a function of the column density. There is a statistically significant drop in the ratio of the H-alpha luminosity to hard X-ray luminosity of about 0.6 dex. And this decrement translates into a systematic underestimation in single epoch H-alpha based black hole mass measurements of about 0.3 dex, when the obscuration is higher than 21 in log units. Similarly, this effect is also experienced by the infrared broad lines, but it occurs at around an H of 22 in log units and by a smaller amount. So the take-home message is that single epoch H-alpha mass measurements should not be adopted when the NH is greater than 21 in log units, and a loss biased proxy for the BLR radius should be adopted, like the hard X-ray, as I proposed at the beginning of the presentation. Using two independent black hole mass estimates, we can compare the two black hole mass measurements for our sample of Seyfert galaxies, and we find an overall agreement within a scatter of 0.5 to 0.65 dex between the two black hole mass measurements, and we also find some hints that the scatter between the two mass measurements might depend on the full width of maximum of the broad infrared lines, as it is expected in the case in which the emission lines get broadened with the increasing inclination angle. We can now see whether the black hole mass deviation, which is basically the virial factor, is scaled by a constant value, which is called F naught in the presentation. We can see if this black hole mass deviation depends on some additional parameters. So our analysis shows that the virial factor do not depend on neither redshift nor column density, but there is a mild dependence with the black hole mass, as you can see in the plots, that report the rescaled virial factor as a function of the black hole mass measurement. This anti-correlation with the black hole mass might be indicative of a more fundamental relation with the full width half maximum, since the black hole mass is related to the full width half maximum squared, but this will be further explored in a separate paper. So in summary, our analysis demonstrates the critical impact obscuration can have on BLR characterization and hence on black hole mass measurements, and that the virial factor is not a constant valid for the whole AGN population. And I thank you very much for your attention.